Hey everybody, and welcome to Igloo today. And today it's like, what is it? It's like 1:30 in the morning, and this thing has been bugging me like crazy. I finally got it done, and I can't wait to show you guys pretty much what this is. Alright, so what this is, honestly, is a setup where I have been working on for a long time, and it's been a dream project of mine to get this like really off and running. Well, here's Mr. Astronaut right here, but I'm working with, what is it, CAD, and I haven't did CAD since high school, so I was just like, you know what, nothing's out there in the world, so I'm going to design it. So this whole setup right here is pretty much just a motherboard, and then you have the GPU in the back, and the whole thickness of the outer thickness is 4 inches by 14, or you can have it 4 inches by 15. As you can see right here, it's 4 inches by 14. This depends on your motherboard and a few other things when it comes to this, but I settled on this. This can be modified to your discretion or whatever if you're going for it. So a couple things that I want to point out before I start explaining this in depth with this kind of setup is that this is the cutout for all of your stuff, for your motherboard, for your graphics card, for all your USBs and everything else. This is your setup where you would pass through this and put it through, and then like you would have like another piece right here, and you would glue it through, because again, this needs to be airtight system. So there's a few other things that are going to be here. There's also going to be clamps. Clamps are going to be here and here, and probably you would have a little bit thicker here for the clamps, and then you just put a clamp right there, and you make sure that all of these have just the gasket on for it. And of course, these are like 360 rads. You can put on 360 millimeter rads, and this is for active cooling without a pump. That's the whole thing about this, is that it's without a pump. And the fluid that I would be designing this all around is 3M 7100 engineering fluid. You can look it up. That's pretty much what a lot of people have been doing, and I've had inspiration from other people where they put this cool stuff out there, and it's in these case designs. I just like the seeing of bubbling liquid, especially when it's actively showing you that it's working, and it's part of kind of why I like this kind of setup. So I designed this with 2 different setups with 2 different sets of cooling. One set of cooling, which is passive, which is not needing a pump, just needs to be set up. And you don't even need to have fans with this, but I would recommend having fans, especially if you want to have the condensation to go back down and you want the pressure to be lower. Pressure regulators will be pretty much controlled directly by the fans, so you're going to need to have just a controller for it, and then you would need to have a pressure sensor inside the module in order for you to make sure you regulate the temperatures properly, and your RPMs would ramp up if the pressure gets higher in this regard. So I have this in a few different ways, and you'll see this over here where I designed this in a very cool extent. So first you have the tank, which is over here. Again, the measurements can vary, but the design is the same when it comes to this. So it's 14 by 4. Alright, so that's pretty much the case for where you would be putting the liquid in and everything else. You would put your sensor at the very bottom. Now, I would recommend doing this on the motherboard side so that you can be fine. There's also the GPU side. So this is where things get interesting for a lot of people, especially if you don't know a little bit of thermodynamics. So because everything is in a thermal raised regulatory fashion, I have this kind of set up in this specific manner. So the first part, which is right here, so all of your peripherals that you'd be seeing in the back, which would be right here. You would file all of them through here. These are just extra holes so that all of the boiling liquid, which will go through here. The condenser is right above this area, which would be for the liquid and stuff. I just did a quick drawing for it. Again, this wouldn't be to scale. It would be suspended by the two pipes that you would have fitted through here. Again, it's going to be like this. This is one phase of the coolant system which you would have, which if you had something directly connected to it, which would be either like maybe a refrigerant system, you would have a water system, or a pass-through system, some form of system which would actively cool it using either glycol, water, or refrigerants. Some form of this can be done. Of course, you can do it in liquid nitrogen if you really wanted to, but I would not recommend it, especially in this setup. This is mainly for like a vertical, like 2U server setup more than anything else. And that's how I have designed this for more than anything else. So again, you have those holes, and then you would have a PCI plane which would go around this little thing right here. There's just enough clearance for you to bring a PCI cable around while it's outside the actual setup, and then you would be able to mount it on the other side. So because it is mounted on the other side, now you're thinking, where's the heat sinks? There is no heat sinks. It's literally just bubbling in, and you can do it right on the IHS. Now, when you want to have something for a little bit better thermals, you would want to stretch up the IHS so that you can actually have enough surface area, instead of the other way of thinking when it comes to like connecting a water block or an air cooler or whatever. When it comes to this, you want to have a smooth contact as possible so that when you apply the thermal paste and then you put it on, you have the closest connectivity to your actual contact point so that you can dissipate the heat. So with that said, that is the active part of the this is an active portion of the cooling, which you would do in a separate second stage setup, especially if you're going to go for overclocking on top of this as well. So not only including the actual air cooler setup air water cooler that I have set up, which I will explain to you in a little bit, but with this setup, it is extremely overpowered already when it comes to it. You can close it off. Now, I have this in modularity, so if you want to, right here, there is the actual cap, so you can actually seal this up. So you don't even need to have this. If you're going for an active system and you want to have the smallest surface area as possible, you have cooling somewhere else, or somewhere else in the server rack, or just somewhere else entirely, you can just seal this up and you should be good. As long as you have your water system running, you can be hyper efficient when it comes to this route. Now again, this is just for 1 unit, so if you're using your gaming PC or whatever, this is something that I have pretty much designed and thought out in this way, shape, and form, where it would be the most easiest to just be like, that should work. And because all of the gas is rising, it would not only go through there, but then it'll also have a passive cooling effect on the very top, also doing condensation in order for it to drip down. Now, again, this system works with both things working together if it was really necessary, but again, it's not. So this is a separate unit which is on top of this right here. So you have right here the intakes for each one. Now, of course, because the air is rising, you will be able to have this, and it would be a higher pressure environment when it comes to just having the two, if you just had this as one system running rather than as two. So because you're having the one system running, you actually have this set up to be really nice when it comes to this kind of integration. Now, I designed this. This can be for like 240 millirads. This can be for whatever, but I have this for 3 of them. Now, you're probably wondering where the power supply would be going. Now, that would go right here. Okay. You can funnel it through the holes, or you can just completely drop this area and you can CNC something different in where these holes are right here. And you can put all of your connectors facing down so that your system is still within the loop and you don't have to have an extra connector going through everything. And then you just have the AC cord that is just sticking out on the top, and you have the switch on the top, so you can do that type of maintenance as well if need be. But again, because everything is going to be snipped together, as well as there's going to be a gasket here, and I should say from the red point, because that's the center points of everything. There would be a gasket right here, there'd be a gasket at the very bottom, and that's it. 2 gaskets, and it's 3 parts. Now, it would not be a lot. Now, if you are wanting to have this type of thing built, of course, it's going to cost you if you're going to be custom building it on top of everything else, which that's what I'm going to be doing. But you want to have a completely sealed unit when you're operating this as well. It needs to be airtight. You're going to make sure that you can operate between 1 atmospheric pressure and 2 atmospheric pressures in order for you to be at its very max. And again, it is a very clean and neat build. Make sure that everything is here. And what was the other thing I wanted to touch up on? The other thing is that when I make this transparent, you will see here, and I will zoom in because this is weird. I made sure so that if you made like water cool fittings, that they would not interfere with the actual just condenser, which is right now. I'm trying my hardest right now because it's being weird, so that it would not hit. So there is a good amount of clearance when it comes to this pipe and over here. So there is, I think the tolerance is 0.2 inches, and I don't know what it is in millimeters right now, and it's almost like 1:40 in the morning. So again, it's pretty nice that I had this set up. Everything is in line. It's just really nice. And I just placed this here for conditional reasons. It's not there just for, of course, this can go lower. Okay, that's a no. Just get here. This can go lower if it really wanted to. This can go higher. You can have everything to be set up and compartmentalized in this way. And again, it's really simple. If you have something like a 16U setup at your place of work or whatever, this is acceptable. But if you don't, you can just throw this off. And you can make sure everything is good. You have all of your linings and setups, because at max, this is only 18 inches high. So when you're setting this up, and then you put maybe you want to put a radiator behind it. So not the motherboard side, because you want to actually see the motherboard side. So you would do it the graphics card side. You would put all the stuff behind here. So again, where all the I/O and everything is, you would put everything just have a hard time. There we go. You would put like maybe the power supply right here, and then you would put like maybe like two 360 mil rads right here with a spacing clearance, so that you can have some fans going through it, so you can have some airflow. Of course, it's not the most optimal solution for it, but you'll be using this condenser, and then you'll be using a pump, which you would probably put underneath the power supply, because that would be the lowest point. You need to have some form of lowest point of contact, and you probably just work around that kind of design, and it'd be pretty cool to have just like a little compact case that is being like controlled by 3M engineering fluid, and it's boiling. And that's kind of why I would design this. I mean, the whole concept is that I would just design this just for the cooling, because it'd be so dope to just see like boiling liquid. And I made it so that it would be the smallest volume possible of using this actual liquid, not just like converting a water block that is just on a CPU and then making sure that the radiator is on top of a case. And it wouldn't be an exact radiator, because it would be like a pool area, and then there'd probably be like some Peltier systems on top. I don't want to do that. I would rather have something that's completely mechanical. The less things that I need to worry about, the less failure that I would have completely and throughout. So that's why I'm using just off the shelf stuff when it comes to most of this stuff. And same thing with I would just have regular copper tubing and I would just bend it a lot. This is just for example purposes. So I'd be like, yeah, this is pretty dope. This is something that I would like to do. And I'd probably use some form of polymer to keep it together. And then I would just seal everything and making sure everything would be fine. This is just a draft that I had as a personal dream of mine, to actually just put this out there in the world and just be like, look, this is some pretty dope stuff and you might like it. This might be something that you could even do, and hell, you can even have this on a wall mount if you really wanted to just show off everything and just show off everything on one side. Maybe you don't have a lot of space when it comes to an apartment, so you might need this as well. If you want to just like put it flush against the wall or something like that, and you want to just have like maybe one or few different cables going down, especially if you have USB Type-C. You might just have one cable go all the way down and then have just a USB like hub right at your desk. Again, it's something that can be very versatile if you know what you're thinking of when it comes to this type of cooling solution. But again, it's not for the faint of heart. This is something for the prosumer. The reason why some people say enterprise that it cannot be for the prosumer is because the liquid is very expensive. I think 1 gallon is like $500 or something like that. But again, it's still in the realm of the prosumer market if they know what they're doing. And honestly, you can probably get away with using, I would say, about like 1.5 liters of actual fluid so that you can get the proper amount of cooling. Again, it's the liquid, which needs to be active on all heat surfaces, and then you have to have a condenser area so that you can cool down that said thing that is heating up the product, and then it will then precipitate back down into the liquid and also cooling that liquid that is in that spot. If you guys like this kind of content, please leave a like, leave a comment down below. And yeah, I'm tired. I spent a lot of time working on this, and hopefully I can get this idea into fruition. I would love to be able to be putting this kind of design, because again, this is my dream build, and I just had to crank down today, and I just put all my passion out right here, and I was just like, you know what, I'm gonna get this design done. And yeah, have a good one. Peace.